All right. Hello, everyone. My name is Garrett Raska. I am the Solutions Architect Lead here at FeatureBase, and today I'll be speaking with Patrick O'Keefe, who is our VP of Engineering. Today, we're going to be going through some of the decision-making behind our SQL implementation, starting with the origination and going through with some of the intricacies of developing it and where we're going. So Pat, to start off, I know that you just are in love with SQL, but we want to get some of the why behind it. And FeatureBase, or formerly Molecular, had started off with its own DSL, which was Pequel. And I just wanted to get your thoughts on how you started thinking about a new DSL and why you chose SQL. And we'll start there.
Sure. So FeatureBase at its core is all about being able to sort of store data and ask questions of that data and ask questions of that data in different ways to get different answers back. That sounds an awfully lot like a database. And so you know, the industry standard for querying languages for databases is obviously SQL. Mm-hmm. And if you want to build a product that is easily adoptable by the largest number of you know, technology professionals out there in the world, obviously, you know, allowing them to reuse their knowledge by providing SQL as a language to query and manage a database is a no-brainer. So that's the basic motivation behind adding SQL capability to FeatureBase.
So a large part of linking to what people are familiar with, what they may have existing code bases in. So just it was a natural tendency to try to mate those two together and leverage all that prior experience, right? With SQL.
Yeah, I think people's knowledge, there's an entire range of tooling built around SQL. Mm-hmm. You know, folks that are in school today are being taught SQL as part of, you know, data pipelines. So, you know, trying to, you know, unless it has very, very clear points of superiority, a non-SQL DSL, you know, domain-specific language, seems like not a great idea for someone or for a group of people who wants to make their product easily adoptable by as many people as possible.
I see. Before we go deeper with FeatureBase, I'm curious, you know, we see as a database company in technology that there are other DSLs available and it's being implemented and for various purposes, right? Either the underlying formats are different, but do you think SQL will remain or should remain as a, let's call it blanket DSL for all of these technologies, or, you know, just getting your kind of digging into your specific beliefs around it? You know, do you think it'll remain the top dog in this area, or should it go away? Is it actually an ideal language?
Yeah, I think so. I think SQL is here to stay. I mean, it was interesting for those of us in data management or longer careers in data management. I don't know, about the early to mid 2000s, you know, there was a lot of no SQL. Well, you know, we don't like SQL. You know, and I think there was that had its genesis in a couple of areas. One is SQL didn't fit with what developers were trying to do at the time. You know, Web 2.0 was sort of on the rise, and so technologies like document databases, MongoDB, and a lot of key value stores came into being. I think partially to solve some problems that the developers generally had with languages that weren't their normal coding language. There was a bit of a sort of an impedance mismatch there. I think also too, at the same time, there was a lot of talk around you know, monolithic databases not being able to scale. You know, Web 2.0 world, right? Like, the famous video about MongoDB being web scale. For those of you interested, do a Google search on that. And so we went through that period of time, and then all of a sudden, a lot of applications got written, and then the first thing that the stakeholders in those applications wanted to do was like, well, can we report on this data? And then all of a sudden, folks had to go write code to meet those business requirements, and nobody wanted to do that. So people then start putting SQL layers back on top of all of these new crop of databases that didn't have SQL. So NoSQL became not only SQL and not always SQL or sort of thing. So it has been around a long time. It keeps coming back. There's a good reason for that, right? It's particularly well suited to the way that humans reason about data. Relational theory we haven't come up with anything better right now, and SQL is a language that is built around relational theory. So I don't see it going anywhere.
All right. Let's get into developing it for FeatureBase specifically. And so, as we mentioned, we had PQL, and you decided to start to layer in SQL. I guess, framing some questions. How did you think about where to start? ANSI SQL is pretty robust. There's thousands of expressions, functions, etc. So where did you start, and then how did you think about layering it into the existing product?
Sure. So yeah, we there is no standard. Well, there is a standard for SQL, but nobody follows it, right? Yeah. I mean, at its core, it all sort of looks the same. Generally, where it tends to differ is around the edges, right? So, join syntax might be different, slightly different. There might be different options to do things, particularly into the realm of stored code or schema management or some of those sort of edges. We start to see differences. Scala function names are going to be different between different databases.
Sure.
And I think that's all okay. So we sort of started with SQLite as a model. We had some code that some folks had contributed to here at FeatureBase that had written Alexa, a scanner, if you like, and a parser for SQL that was built around like a syntax very similar to what SQLite supported.
Okay.
We've since evolved that to approach things slightly differently, right? So there's some stuff, for example, that SQLite will do that the current SQL implementation for FeatureBase won't do. We don't have a create index statement, for example, right now.
Oh, I see.
That we will, but currently right now we don't. But there's a few choices that we made along the lines of that, where our current implementation either doesn't need to or does not yet support some of the features. Common table expressions are another one. We will support it. We just don't right now. Haven't done that work yet. So we took that approach, and then we started thinking about, well, how do we expose some of the goodness that FeatureBase allows for through SQL? So one of the things that FeatureBase is very, very good at is this notion of a set column. So we allow very, very fast queries on very high cardinality data if you need to do aggregates, right? So this is very useful if you're doing any form of segmentation type query, right, where it's group by stuff and counts. And our set column is particularly good at that. So filtering on sets, inclusion, exclusion, intersection, union, all of those sorts of things. How do you expose that through SQL? So we've taken the approach of using both scalar functions to support that functionality, and then the plan optimizer will rewrite that appropriately underneath. and in the future, we will likely support some of that stuff as like nested relations.
Mm-hmm.
So then you can just use a simple join syntax to unlock that functionality. So that's been our approach, is SQL where it makes sense, and then we'll work out how to expose the things that make FeatureBase really powerful through various means.
Right. And for those people tuning in that aren't as familiar with FeatureBase, it's built on a different storage format, which is roaring bitmaps, right? So given that, is there anything that you've come across that's just strange, that maybe a different database, maybe named a few Mongo or others that have SQL interfaces, that was just kind of strange to try to develop around just due to that format?
Yeah, I think so. Sets in particular are one that folks often get confused by. It's like, what is this? People sort of think, because they look a lot like an array. Here's an array of values, but it's a set. So so is this member in this set? And then how to reason about that from a data modeling perspective has been finding a way to communicate it, communicate the value of it to customers or people looking at FeatureBase for the first time has been, potentially more difficult than
actually implementing some of it. I see.
Yeah, the implementation part of it was relatively easy. So,
all right. Before I move on, any part of this that you enjoyed a bit about having to figure out the optimization layers, or was that more of just nitty gritty, or was that actually like, okay, this could be an interesting challenge to try to tackle?
Yeah, I mean, all of it. I've had I'm not done yet, but I've had a pretty long career in products in and around databases and databases itself, and so building this stuff has been a lot of fun, and building a team around it that can build this stuff has been a lot of fun. So yeah, I've enjoyed all of it.
All right. And you mentioned SQLite being the origin model, or it's taking some bits and pieces from that. Were there any other SQL models that you had in mind that you kind of piecemealed together, or is SQLite the kind of core and you just went from there?
Yeah, so I mean, we've borrowed stuff from our goal is to be usable and easily understandable. So we've borrowed stuff from a lot of places, right? So we started down the path of SQLite, but there are some things that we can do that aren't supported in SQLite, and so we've borrowed from MySQL, we've borrowed from Postgres. Our command line, one of the things, as an aside, one of the things that SQL lets you do is if you think about our database product in layers, right? You have a storage layer down the bottom, and then over the top you have a language layer. If that language layer is SQL, so everything you can do in the database, you can do in SQL. So query, manage, look at manage the state of the database. So what is the database doing? Well, I just go query from a system table, which tells me what it's doing. What queries am I running? I can go query from system table. All of that stuff means you can now build a tooling layer on top, which is exactly what we've done. So so we have a thing called FB SQL, feature-based SQL. So a command line tool, for example. It borrows pretty heavily from PG SQL, so that's the Postgres world, and for a lot of good reasons. Steve Jobs said, "Great artists steal."
Right.
So we borrow the best from wherever we can, right?
Absolutely, yeah.
So there's that. If you look at a lot of the scalar functions that we have, some of them have been borrowed from all over the place: SQL Server, Oracle, Postgres. wherever it makes sense.
Got it. So it seems like there's this general theme that SQL and let's call it borrowing some of the more well thought out and well implemented projects and absorbing that into this is unlocking some areas. Have you noticed over the original SQL language that was used to interface with FeatureBase, is SQL expanding that? And can we do things like you said, system table information, learn more about the underlying cluster with it? Is there anything else that you would say has been unlocked, or that users would be able to access that they couldn't previously?
Yeah, absolutely. So SQL, well, the obvious one is SQL didn't support in any meaningful way the concept of joins.
Mm-hmm.
So that had some knock-on effects too, right? Mm-hmm. So every conversation that we would have with someone who was trying to use FeatureBase very quickly become a how do I model data conversation, because and you couldn't have that conversation in again industry standard relational terms, like I go create this table and I go create that table and I can use third normal form and I can join and do all the things you'd expect to be able to do. So that's all gone away now that we have SQL. I think secondarily, if you want to do basic arithmetic or expression evaluation, say for whatever reason I want to add 10 to every integer value that comes back in a query, mm-hmm. You couldn't do that in SQL. Now we can do that in SQL. One other great example for FeatureBase is our bulk insert statement, right? The ability to do mapping and transforms, lightweight ETL, if you like, inside a single statement, so that incoming data can be transformed, and it becomes composable, right? So if you have a transform clause, for example, in a bulk insert statement that lets you take some data out of your source data that's a string, and you want to slice that up, you can wrap that in a scalar function call to do that. Later on down the road, when we support user-defined functions, and let's assume for a minute that that user-defined function may take a string and return an embedding, right? Because it goes and actually does a model in AI terms. Now all of a sudden, this all becomes composable, right? So when you start ingesting data, you've got a string and you want to turn it into an embedding. You can do that just by changing the transform clause in your bulk insert statement, and life becomes very easy in that world.
Yeah, it sounds like that users would be able to jump in and not have to worry too much about little nitpicks on data, which we see very often. It's not uncommon to find a comma or a backslash or some type of error in a very large file, whether that's batch or streaming for that matter. So allowing the users to do this type of functionality, transform it coming in, will keep their attention focused on actually working with the data, discovery, and generating interesting things about it, rather than fighting it to try to get it into a data store. And then once it's in, and you got a little ahead of me, we're gonna get from the now into the speculation here quickly on. You mentioned some modeling, some AI, and we all have seen that start to grow in the industry, and data stores and databases be used and seen as powering these, right? Before we jump into that, let's cabinet on SQL specifically. So far, how long has the process been from, let's say, start, wherever start would be, to now? How long has it been for developing SQL?
Where are we now? We're at end of March. I would say about the last 12 months.
Okay, so about 1 year.
Yeah.
So about 1 year of development. If you could go back and start fresh again, would you change anything that you've done or order or anything about that so far?
Yeah, at this stage, I don't think so.
All right.
Like all of these things, that it's always a learning experience, and there's missteps along the way. Would I change anything about that? No, I think making the mistakes along the way is how you learn, right?
How we learn, right? So, all right. So happy with where we're at today. Now, moving forward, right? Let's get into a little bit of speculation. So, obviously, SQL is still one of the premier primary languages that is used to interface with databases. And as we start thinking about ML and AI and kind of bringing this technology forward into that, do you see SQL evolving either, intra feature based in our technology to bring us to that future, right? Being able to run models, be able to do inferencing, things of this nature in that, that DSR DDL type of language, or what are your thoughts on that?
Yeah, I think so. Like one of the things that we've been toying with internally. Well, let me take a step back. One of the things that SQL lets you start thinking about when you implement like a language layer on top of a database is you start thinking about, well, what's data access paths look like, and how because it separates the how I reason about the relations, like in terms of relational theory, how I reason about the tables that I have and the data versus how I optimize answering the queries, right? It separates those things in a very real way. And so there's lots of opportunities for increasing performance, increasing storage efficiency, increasing the all of this sort of under the hood stuff. So taking advantage of modern CPUs and modern technology, for example, SQL's relational, but the storage underneath it doesn't have to be. And FeatureBase is effectively at its heart a column store data, like a column-oriented database. So if you're a column-oriented database and on some stuff that you want to be able to do scans, like vectorizing that compute underneath to take advantage of modern CPUs is something that we're looking at as part of this effort at large. So that's one thing. The other thing too is I think that there are language structures that are layered on top, which should expose some of this functionality too. Why can't simple models, leaving aside like large language models and a lot of that sort of stuff, even basic stuff like linear regression, or I want to do a k-means, or I want to do even some basic statistic functionality. Why are those things not just schema objects, or in some cases just intrinsic functions? So can I do a create model statement, for example, because I just want to do a basic linear regression to predict some number in terms of a bunch of other numbers. So there's those sorts of opportunities, I think, being able to make those things sort of like first-class language features.
Okay.
I think secondarily, there's some other stuff that we can do around, and we're planning on doing around pushing. If you have that stuff in the database, and I talked about sort of like language layer and tooling layers before. If you have this stuff available in the language layer, then you can build tooling on top of it. So we can apply some of that stuff. It's like database inception, right? We can apply some of that stuff to ourselves. So when you ingest some new data and you're trying to work out like, what have I got? What's valuable? What's interesting? What's not interesting? What can I ignore? There's a bunch of stuff that we can do around just analyzing data for the data engineering and the data science process at early stages, like trying to work out which of these 30 columns correlate to each other.
Oh, just EDA style or exploratory.
Yeah, that's all of that sort of exploratory stuff. Like we should be able to do that with a SQL statement.
Just be quick.
Yeah. And provide summaries. Here's the things you should care about. Here's the things that you shouldn't. Here are the things. Here are the columns that you should make features out of if you're doing some sort of machine learning exercise. Here are the things you can ignore. And adding that capability to the language layer. Again, lets you build a tooling layer on top to expose all of that stuff and again make it easy.
I see. And today we are exploring user-defined functions. You mentioned that as we started, right? So allowing those to run. So there's a lot of thinking that goes into that, obviously security that needs to be addressed, et cetera, but setting that aside, when you mentioned these tooling layers, currently all the tools that we develop for FeatureBase are usually developed in-house, right? We do have an open source project that any developer can go join and do commits and PRs against. But most of that tooling is done. Do you see a time when that language layer would allow third parties and other people to develop their own tools for FeatureBase? Is that something that you're looking to do, or do you think the tooling that we've developed in-house will probably be the primary?
So it's hard to if you build language layers on top of, I mean, you're effectively building a platform, right?
Yeah, sure.
It's not our goal to set out, at least right now, to be a platform. I think we build the product first. If our customers start using it that way, and that's what we're trying to enable, we will become a platform, and that would be a good place to be. I mean, we already have customers talking about doing some of this stuff today. So, for example, I think even as late as this week, we just shipped some additional capability that we've had some. Well, let me take a step back. We've had some capability for a while to where we've had a piece of software that can take data from a Kafka topic, batch it all up, and send it to FeatureBase to do data ingestion. We released some capability earlier this week that can, where we have a piece of software that can talk to a Kafka topic and insert data into FeatureBase, except it's doing it with bulk insert statements, not direct to the wire stuff like it was before. The benefit of that, of course, is that whatever version of FeatureBase that you have, whether it's the on-prem community open source edition or it's our current cloud product, all of that just works.
Okay.
A customer can take that code, that's all open source. A customer can take that code and say, hey, I have a use case which your implementation doesn't quite meet.
Sure.
You know, I want to, every time I pull a thing off a Kafka topic, I want to do some other lookup and that's specific to me, and they can go build that themselves. And that's I think will make the easy path easy. And I think our goal is to make the complex path or the difficult path possible.
Cool. All right. Well, we're coming up on the end of the session. So Pat, thanks for taking time to educate us on your adventure through SQL as we've implemented here at FeatureBase and answering some of these questions.
My pleasure.
Yeah, stay tuned, and we'll see if we do another one of these, but thanks again.
Thank you.